Good morning, philosophy class. We're looking today at variations on deductive reasoning. You'll see in the text it also says paradigms of standard form. A paradigm is like a model of something or a typical example of something. You don't actually have to know the word paradigm. It's just it's the word they use in this particular text. What you need to understand that these are forms of deductive reasoning. Because they are forms of deductive reasoning, if you can identify that an argument uses this form, then you know for sure that that argument is valid. Okay, that's what you need. It doesn't mean that it's sound. It may still be a bad argument. There may be problems with the premises, but you know that if it uses one of these forms, that the argument itself is absolutely logical, totally logical. All right. Before we get into the specific forms, there's two terms that I need you to know real quick, and I want you to get your notes out, open up a Google Doc or whatever, and you're going to need to jot down these two terms. The first one is antecedent, and the second one is consequent. Yeah, I'll show you in just a second. A lot of these arguments, these standard form arguments that we're about to look at, use if-then statements, like a conditional statement. If this happens, then this other thing will happen. And in an if-then statement, you have two parts. The if part is the antecedent. Ante means before, not anti as in against, it's ante. And the then part is the consequent, or the consequences of the first part of it. So you're going to see these two terms come a lot, and I'm going to use them to explain them. So you need to make sure you understand that. So if our if-then statement is, if Mr. Parsons tries to cook, then his family is going to go hungry. Okay, so the antecedent is me trying to cook. All right, the consequent of this thing is my family going hungry because I was cooking. Okay, all right, we got those two down, antecedent and consequent. Okay, so let's look at the first example. First one, brace yourself, this is Latin, so I'm going to have to write it out for you. First one is modus ponens. Bam. Okay. All right, a modus ponens argument, write this down, is when you affirm the antecedent. Okay, modus ponens is affirming the antecedent. What that means is in the if-then statement, in the first premise of the argument, I give you the if-then statement. In the second premise, I affirm, modus ponens, I'm going to affirm the antecedent. So I'm going to tell you that the first thing did actually happen. So the first statement is, if Mr. Parsons cooks dinner, then his family is going to go hungry. The second premise, I'm going to affirm, I'm going to say Mr. Parsons did actually cook dinner tonight. All right, so there we go. So we can, because it's a modus ponens argument, we can conclude with absolute certainty that my family went hungry that night. Okay, if you look at the example in the text that you were given, it says, where is that one? It says, if the cookies are golden brown, then they are finished baking. All right, and then we affirm the first part, the cookies are golden brown, and therefore we can conclude that the cookies are finished baking. Now it seems very simplistic, but you need to understand, I took an if-then, and I said yes to the first part, okay? So the next type of argument is called modus tollens. Modus tollens is the logical opposite of modus ponens. Here it is, modus tollens. And modus tollens, we, instead of affirming, we deny, and instead of the antecedent, it's the consequent. So modus tollens is denying the consequent. So if we look at the example that I gave you about me cooking, if we said, if Mr. Parsons cooks, his family's going to go hungry, and then in the second premise, we deny the consequence. So my family did not go hungry. Therefore, we can conclude with absolute certainty that I must have not cooked that night, right? Now, remember, this is about it being logical. It's being valid, not about it being sound. So I'm actually an amazing cook. You should see me make crepes. It's great. So if I cook, that wouldn't really happen. But if we're accepting that first premise is true, and then we accept the second premise is true, then we have to have that one conclusion, all right? You've got the example in your text there. It says if the cookies were golden brown, then they would be finished baking. But the cookies are not finished baking. So we know that they must not be golden brown yet, right? What gets tricky with modus ponens and modus tollens is sometimes in arguments, people will try to do the opposite. Some people will try to affirm the consequent or deny the antecedent. And let me show you what that looks like. We'll do the cookie one still. If the cookies are golden brown, then they are finished baking, okay? The cookies are not golden brown. Does that mean that they're, oh geez, hang on a second, it's light. Automatic lights, nobody's in the classroom right now. So I denied the first part, the cookies aren't golden brown. And so I'm gonna try to conclude that they aren't finished baking, but we don't know that. All we know is that first premise. If they are golden brown, then they're finished. But we don't know if there are other circumstances, other qualities that might also make them finished, all right? So beware of the opposite of modus ponens and modus tollens. Yeah, I know, it's tricky. You're gonna practice, and we'll talk about it, so don't worry, don't freak out. The next one is a hypothetical, well, I better write fast, hang on. I can't write that fast. Hypothetical syllogism. Somebody asked me, my background is in math and science. Somebody asked me why I went from math to English. And I told them that math and English are the same thing. And everybody thinks I'm crazy, and you're about to see why. Hypothetical syllogism. That's when I give you really it's an if-then statement. It's still a conditional. And then I give you a second conditional that relies on the first one. So if I say, you'll see it's also called a slippery slope, but a slippery slope is actually the bad way of doing it. We'll say, if Billy comes to school every day, then Billy will pass his classes. If Billy passes all of his classes, he'll graduate high school, all right? So then I can take that middle part out and say, if Billy comes to school every day, he'll graduate high school, all right? I don't need the middle part, and that's what a hypothetical syllogism is. You create a hypothetical situation. It's actually the exact same as the transitive property in math. If A equals B and B equals C, then A equals C. I don't need the middle part anymore. So English is math, sorry. Sucks for you guys that hate math. It sometimes takes a mathematical brain to deal with philosophy, especially in this first unit when we're working on logic. Right after hypothetical syllogism is chain reasoning. While I'm writing that down, let me explain what I was saying about slippery slope. That hypothetical syllogism, that if this happens, then this happens, and then if this happens and this other thing happens, people misuse that all the time. They'll say, oh God, we saw it a lot with this coronavirus stuff. People are acting like all of our freedoms are going to be taken away, and the new world order is coming, and you're all going to be enslaved by the government, and you're all sheep for wearing masks. And I'm like, Jesus, dude. Like, just because one thing happens doesn't mean that the next thing necessarily happens, and that's the difference. In a hypothetical syllogism, it's only logical if each conditional necessarily follows from the one that came before it. All right? Yeah, I guess it's possible that the New World Order is coming and that Trump's going to declare himself emperor, but just because one thing happens doesn't mean that the other thing is necessarily going to happen. So that's what you got to watch out for. Next one is chain reasoning. Chain reasoning is the same thing. But instead of conditional statements, instead of if this, then this, it's just the transitive property. The example of it you're going to see in your text is very easy, very clear. Nellie is a dog. A dog is a mammal, and so therefore Nellie is a mammal. We're going to get into categorical syllogisms next week, and this is actually a good example of a categorical syllogism. Don't write that down. Never mind. Pretend you didn't hear that. You're not going to want to hear about categorical syllogisms yet. They scare some people. So I love them. I think they're hilarious. So last one then. After chain reasoning is just A equals B, B equals C, therefore A equals C. Last one is disjunctive syllogism. Disjunctive. S-Y-L-L-O-G-I-S. Some of these philosophy words, you say them too many times, they start sounding weird in your head. Disjunctive syllogism. Okay, all right, what I've got in a disjunctive syllogism is an either-or statement. Okay, so I've got an either-or statement, and I'm going to say either this happened or this other thing happened. And then I'm going to disjoin them. I'm going to say that one of them didn't happen. All right, either, you see it with a false dilemma a lot. Either you graduate high school or you're going to end up as a crackhead, okay? you didn't graduate high school, so I guess you're a crackhead. You know, there we go. So I did not, I just joined them. Say I've got an either or, and then I said one of these things didn't happen, so the other thing I guess has to happen. It's logically perfect, okay? I know what I said was not accurate, but it was logically perfect. It was a valid argument, it just wasn't sound. The first premise about the either or, graduating high school or being a crackhead, that's obviously not true. But if it were, then the rest of it logically follows, okay? So let's practice these. You're gonna look at some arguments, and you're gonna identify which form of the deductive reasoning, which paradigm is being used, all right? Good luck, guys. Don't forget to use Canvas chat room or Remind if you have questions.